Hello children, good morning. I hope you are doing good with your studies, and we have completed some of the topic, very important topic. And today's topic that we are going to take, that is the capacitance, and the capacitance is the collective of all the topics that we have done earlier. Now when we talk of capacitance, then we need to understand the two things. What is the first one? One is the conductor, the other one is insulator. Now you all know that when we talk of conductor, then the conductor is mainly just because of the free electrons that it is having. Any sort of conductor contains lots of free electrons and they are the charge carriers. But when we talk about the insulators, then these electrons are bound electrons. They are not able to move that freely, and that is the reason the conductivity is not seen. But we have got one more very important part, that is what we call dielectrics, which we are going to study in details later. Dielectrics. We'll study about it in details later on. So it is another category of insulator, but there is some differences. When you take this dielectric and put it into an electric field, then what you find that the electron experiences a force. F is equals to QE is the charge of electron, and since it is experiencing a force, so what exactly happens, that there is a net conductivity and they get accelerated, but the direction of their acceleration is just opposite to the applied electric field. That is what we will do it in dielectric. Today we are going to talk about the topic capacitance. Capacitance of the conductor. We are going to talk about capacitance of a conductor. Basically what we mean by the capacitance, it is the ability of the conductor to hold the charge. So when there is a conductor and it can retain the charge, it can hold the charge, then we call this as the property of the capacitance. Okay, and it has been seen that there are two things that is very important for C to come out, that is the charge and the potentials. Okay, so if we can see that here Q is directly proportional to V. Q is what? This is the charge. The more you have the potentials, actually we talk of potential difference, then you have more of the charge. So what we find that Q is equals to CV, or C is equals to Q by V. Right? So the basic unit, SI unit of charge, this capacitance, SI unit, capacitance is farad, or you write capital F. You can also write this is the coulomb and this is the volt. You can also write coulomb per volt. And since it is coulomb per volt, so you can easily get the dimensional formula of it. How you can get the dimensional formula? Let me write here. Dimensional formula. Dimensional formula. Now, this is what we got C. C is equals to what? Let us write C, and this is what? Work done by charge. Work done by charge. Let us take it as Q only. So it is Q square by W. Isn't it? Now Q square is what? AT ka whole square. And here it is ML square for the work done, ML square T to the power minus 2. So ultimately what you are getting up? You are getting up M minus 1, M minus 2, A, and T to the power, it goes up T to the power 4. So this is the dimensional formula that you get for the capacitance. It's easy to do. Only thing that you have to do, C is equals to Q by V you are getting. Q is what? V is what? Work done by charge. So that goes up Q square by W. Q square is 80. Current into time. And then you have the work done. ML square T to the power minus 2. And then you just solve, you are getting your values there. Okay, now the capacitance of a conductor depends upon the shape, size, many things, okay, which we will be finding out later on. We are going to study in details about it later when we do with the capacitor. But today let's find out the capacitance of a spherical conductor. Suppose there is a spherical conductor and its radius we have taken as r. Okay. Now when you give the charge is going to reside at the outsides. So what you need to find out? You need to find out C. Now the potential at this point, the potential V is equals to 1 by 4 pi epsilon 0. The charge given, let us assume the charge given is plus q. So q, and the distance from here we take it as r. R becomes what? R becomes the radius of the conductor. Radius of the conductor at this point. That is serving as a distance. Now C is equals to Q by V. So Q divided by 1 by 4 pi epsilon 0, Q by R. Q is getting cancelled, so C is equals to 4 pi epsilon 0 R. So that is the basic formula for the capacitance of a spherical conductor. So that is how we calculate. So if you want to calculate the capacitance, what are the basic things that you require? First thing that you require is the charge, but before charge you need to find out the potential. So when you do with the capacitors, when you do with anything, the very important thing that we need to do is what we need to do with the potential difference. So becomes very calculative, becomes very confident about the potentials. Once you do it, it's easy to do it. Okay, thank you for the class.